Hey everyone, today we are working on what is called solving the triangle. Okay, so you guys have had 2 days of practice on using SOHCAHTOA to find missing side lengths. You've had a day on finding missing angle measures. Solving the triangle means to do both. Okay, so when you see the directions solve the triangle, number one, find all your missing side lengths. And number two, find all your missing angle measures. Okay, so we're pretty much not doing anything new here today, but putting together your last two lessons, finding sides, then we did finding angles. Now you're doing both. You're combining it all into one. Okay, so before we get started, I want to up at the top here, I want to talk about, I'm going to call it your toolkit for these problems, meaning what methods are you going to use to solve these? So you guys know we've been doing it all week for the last couple of weeks. The first thing is SOHCAHTOA. Okay, so that's what we've been practicing the last few classes. Use sine, cosine, and tangent to either find missing sides or angles. Okay, but now another thing that you may use here is your Pythagorean theorem. Okay, so Pythagorean theorem was the first lesson of this unit. You guys already had a quiz on that. And you can use the Pythagorean theorem when you have two of the three sides. Okay, so anytime that you already know two out of the three side lengths, you could choose to use Pythagorean theorem to find that third side instead of SOHCAHTOA if you're more comfortable using Pythagorean theorem. Okay, the third thing would be the triangle sum theorem. Okay, and that theorem, I think all of you know it, but you might not remember it by name. Okay, and that theorem says that the three angles in a triangle add to, I'm sure you're all yelling it at your screen right now, 180 degrees. You all know that. Okay, so you can use this one when you have two of the three angles. Okay, so looking at number 2 and 3 here, Pythagorean theorem and triangle sum theorem. Okay, you can always use SOHCAHTOA for these problems, but sometimes you can use the Pythagorean theorem whenever you have two out of the three sides, and then whenever you know two out of the three angles, you can use the triangle sum theorem, which is that they add to 180. And I think you'll see, especially with this one here, that it's much easier than using SOHCAHTOA. Once you know two out of the three angles, it's actually much faster and easier to use the triangle sum theorem than SOHCAHTOA. Okay, so now let's do an example or two. All right, the first thing, um, you have 6 parts to every triangle. Okay, you have the three angles, angle A, B, and C in this case, and you have three sides. Okay, so in this case, they would be AB, they would be BC, and they would be AC. Okay, so that's the same for every triangle. You're always going to have 6 things that you need to solve for, 3 angles and 3 sides. When it says solve the triangle, you need 6 answers. Okay, but notice you already have some of them. And I'm going to do in blue, and you should color code yours as well, the things that we already know, okay, which we have 2 of the 3 side lengths. BC is 30, AC is 24, and we see that right angle at A. All right, and it's also very important to notice that you're always going to have a right angle in these problems. Okay, I'm going to scroll through it here and you'll see they always have a right angle. Otherwise, we can't use SOHCAHTOA. The only reason we can use SOHCAHTOA is because it's a right triangle. So one of the things you'll be given will always be 190-degree angle. And then they'll have to give you some other things, like in this case, they gave you 2 side lengths, and you need to use one of these 3 methods here at the top in your toolkit to find the other 3 things. So in this case, we need angle B, angle C, side AB. Okay, so I'll start with angle B. The ones I don't know, I'm going to do in, I guess, green. Okay, so actually, I'm going to do light blue. So we have, no, I changed my mind. I am doing green. Okay, angle B, first thing. And this should be the most fresh in your mind because you just did this your last class. Okay, when I see angle B, I know I need to use the two side lengths they gave me in order to somehow solve for angle B. And I see 24 and 30. And you need to decide between adjacent, hypotenuse, and opposite, which are those in comparison to angle B. And remember, that will change. Like which one is opposite versus adjacent changes depending on what your reference angle is. So in this case for B, I see 24 is through the triangle across from it. That is opposite. And then 30 is across from the right angle. And we know the side across from the right angle is always the hypotenuse. So with O and H, we would be using sine, right? SOHCAHTOA O and H is sine equals opposite over hypotenuse. So sine of angle B equals opposite 24 over hypotenuse 30. And what you guys learned last class is when you know the ratio, you have the O and the H, you solve for the angle using inverse trig. Okay, and that's that. It looks like a -1 power on your calculator. Okay, so sine inverse of B, sine inverse of 24 over 30 equals B. Okay, so when you know the ratio O and H, that is when you use that inverse trig button. Okay, so in your calculator, sine inverse of 24 over 30. And so the measure of angle B, you should get 53.1 degrees, rounding to the nearest tenth. Okay, so sine inverse of 24 divided by 30 is 53.1 degrees. Okay, it was 53.13. We're rounding to the nearest tenth. Okay, angle C. Okay, and this is kind of what I was talking about with your toolkit. We could use angle C, and 24 then would be adjacent, not opposite, and we would use cosine because A and H. Okay, but this is why I'm saying work smarter, not harder. The triangle sum theorem says that the three angles have to add to 180, and now we already know two of them. A they gave us was 90. If B is 53.1, then we know 90 plus 53.1 plus the measure of angle C has to add up to 180. Okay, so if I take 180 and I subtract 90 and subtract 53.1, your answer, the measure of angle C, you should get 36.9 degrees. Okay, so that's kind of what I was saying at the beginning with your toolkit here is only given one angle at the beginning, only knowing the 90, we had to use trig to get the first angle we solved for. But then once we got B, you're able to solve for C much easier than trig by using the triangle sum theorem. And you could have done it the other way around. You could have used trig to find C, then triangle sum theorem to find B, and you would have gotten the same answer. All right, now the last part, AB. I'm going to show both ways to do it. Okay, you could do it using trig. And then this is where you could use the Pythagorean theorem because you know two out of the three sides. Okay, so using trig, if I want to solve for side AB, okay, this is my missing side here, AB. And I'm going to erase some of this other stuff in that triangle. Okay, the only thing I'm going to leave is H because 30 is always the hypotenuse. Okay, so now we need to use one of these two angles, B or C, and we're using AB and H. Okay, so it depends which angle you use as your reference for which trig function you're going to use. So I'm going to use B, and in terms of B, AB is the adjacent. Okay, so A and H, adjacent and hypotenuse, I would say cosine of B, which is 53.1, adjacent, that's x, over hypotenuse, which is 30. Your next step times by 30. Okay, so x equals 30 times cos of 53.1. And that's where you now go to your calculator. And you should get 18.01, rounding to the nearest tenth, 18.0. Okay, the other way to do it, Pythagorean theorem says a squared plus b squared equals c squared, where a and b are your legs, c is your hypotenuse. The one we don't know is side AB. That's a leg. So we have, I'm going to call it AB squared. That's the one we're missing. We'll call that A. B squared, so the other leg, is 24, equals C squared. The hypotenuse was 30. Okay, squaring these other two. 24 squared is 576. 30 squared is 900. Subtract 576. Okay, AB squared equals 324. Now your last step to get AB by itself is take the square root of 324, which is 18. Okay, so this kind of just shows you that both methods work. And I think it's really a matter of preference when it comes down to Pythagorean theorem versus trig for a missing side. Okay, when it comes down to triangle sum theorem for that angle, definitely easier to use the triangle sum theorem than trig. But as far as that missing side AB, you're going to want to, or any missing side, you're going to want to decide what's easier or works better for you. Okay, so this last one, all right, I'll go through it a little quicker. Okay, we have the three angles and three sides. Okay, they gave us angle C is 90. They also gave you angle B is 62. Okay, so, and excuse me, I'm going to go back and put those in blue. If you remember, blue represents the ones that they gave us. Green was the ones that we solved for. The other thing they gave you is AC is 22.6. Okay, so the first thing I would do is for angle A, again, I would not use trig. I would use the triangle sum theorem. You know the three angles have to add to 180. So subtract the two that you know, and the missing angle A has to be 28 degrees. Okay, and you want to check your work, add those three angles, make sure they add to 180. Okay, now we cannot yet use Pythagorean theorem because we only know one out of the two sides. So you'll have to use trig to find one of the side lengths. So I'm going to say I want to find AB first. Okay, so the side length that you're going to have to use is 22.6, first of all, and it depends which reference angle you use, whether that's an adjacent or an opposite. So I'm going to use 62. In terms of 62, 22.6 over here is the opposite. AB, what I'm solving for, is across from a right angle. We know that's always a hypotenuse. O and H, so sine. Okay, so sine of 62 equals opposite over hypotenuse, 22.6 over H. Okay, and these are a little harder, or actually I'm going to call this AB. It's always a little harder when the variable's in the denominator, because when you multiply both sides by AB, it's not by itself yet. You have AB times sine of 62 equals 22.6. Okay, and last step would be divide by sine of 62. So AB equals 22.6 divided by the sine of 62. Now you go to your calculator, type that in just like you see it. Okay, 25.59 rounds to 25.6. Okay, I'm going to put miles because it did have that unit labeled in the picture. And finally, the last thing, BC. All right, same as on the first example, you could use triangle sum theorem, you could use Pythagorean theorem, or you could use SOHCAHTOA. You should get, for BC, you should get 12 miles on the dot. Okay, whether you use Pythagorean theorem or SOHCAHTOA. All right, guys, so right now you're finishing the worksheet, or your teacher may give you a certain amount of them, like just the odds or just the evens. All right, make sure you check with your teacher to see what your specific assignment is. If you guys have questions, don't hesitate to reach out. Have a wonderful day.